All right.
No. Yeah. That's what machines are for.
What does Gronky do?
Nothing. Gavin. He's on pause right now, but he's working also. I don't know. I'm
You
working
don't
at the
know?
office this summer, guys.
Huh?
I'm gonna be a coach.
All right. So we're going to look at first derivatives. And what a first derivative does is it finds the slope
Are you gonna put it on the
at any point.
Yeah, you're gonna let us see what you're writing. I personally won't be that mad if you take the day off. Slope is the m, or no, is the
Slope is m.
Actually, do I have to try?
115, I think you get out.
Oh my god, why do we always have to get out to the
So you're able to find slope at any point. Now, the slope of a line like this is super easy to find.
Yeah, you just go up and over.
The slope of the black line equals the rise over the run, which is equal to 1/3. That's pretty easy, right? So this function is like, oh, I don't know what it is. It would be we have the points 2, 0 and the points 5, 1. So you'd go slope is 1/3, and you use this point and you put it in point slope form. Y minus y1 equals your slope times x minus x1. So y equals 1/3 x minus 2/3. That's the equation of this line. Okay? Okay, so that's all pre-calculus stuff. Okay? That's like algebra. So now what we're going to do is look at a problem that looks like this.
Hey, I'm feeling a little lightheaded because I gave blood to myself lessons.
Sorry. Okay, this is a parabola. I can find the slope at the point 0, 0, at the point 1, 1, at the point 2, 4. I can find the slope at all of them. Are they all going to be the same slope? No, they're all going to be different slopes. So in calculus, what we do is find the slope of a curve. We're going to find the slope of a curve. Now, what we're going to do is just find some slopes right along here for right now. So let's find the slope at the point 1, 1. I want the slope at point 1, 1. All right, to do this, how do you find slope? You find 2 points and find the slope in between them. So I know 1, 1 is a point, and I know 2, 4 is a point on this function. So the slope between 1, 1 and 2, 4 is 4 minus 1 over 2 minus 1, which is 3 over 1, which is 3. So the slope of the line that hooks up between these two is 3. Okay? But I want the slope right here at 1, 1, not the one that hooks up between the two. Okay? So, you can get closer than 2, 4 to 1, 1. I could go, well, what is the slope at 1.1? Now, this function is y equals x squared, right? It's a parabola y equals x squared. Do you trust me?
Yeah.
Trust me, it is. Okay? So, let's say I want to find the slope at between 1, 1, and then 1.1 and whatever 1.1 squared is. What's 1.1 squared? 1.21. So if I want to find the slope between those 2 points, I go 1.21 minus 1 over 1.1 minus 1, which is 0.21 over 0.1, which is 2.1. There's the math of that slope one. Okay? Now, I'm going to go over the graph. I'm going to use some different colors here. The first one was like this. I found the slope between these two. The next one, the point is like right here, and I'm finding the slope here. Now that would be probably a pretty accurate slope for this point down here, right? But I can become even more accurate if I get even closer to this. I keep getting closer and closer to this point. It's like it's a what from last chapter? A limit. As you get closer and closer and closer, the number will actually appear. Okay? So let's get super close. Okay? Let's say we're at 1.001. That's pretty dang close, right? So I'm going between 1, 1 and 1.001. Now 1.001 squared is 1. Might need my calculator. 1.001 squared is 1.02002,001. Okay, so if I wanted to find the slope between those 2 points, I get 1.002,001 minus 1 over 1.001 minus 1, which is 2 point 0.002001 over 0.001. If we move the decimal point 3 places, it's 2.001. Now, my original one had a slope of 3. Then I got down to a slope of 2.1. Now I'm down to 2.001. Where's my limit going towards? 2. So the slope at 0.11 of y equals x squared should have a slope of 2. Okay? The slope at the 0.11 of that function should have a slope of 2. Okay? Should we find the slope at the 0.00? Yes, let's. All right. I want to find the slope at the 0.00. So I'm going to use 1, 1, and 0, 0 as my first points. So if I go 1 minus 0 over 1 minus 0, I get 1 over 1, which is 1. Do you might think my slope is 1 here at this point right down here? Probably not. Then I'm going to go 0, 0, and then 0.1. What's 0.1 squared? 0.01. So if I go 0.01 minus 0 over 0.1, I get 0.01 over 0.1, which is 0.1. Now I'm going to even get closer to 0, 0. I'm going to go 0.001. 0.001 squared is 0.1234 with a 1. So it's 0.00001 minus 0 over 0.001 minus 0, which is 0.00001 over 0.001, which if you move it is 0.0. So what, it goes from 1 to 0.1 to 0.001. Where is it going to there? 0. The slope at 0, 0 should be 0. It's a horizontal line. When the graph turns around, it's a horizontal line. Okay? The graph right here would have a slope of 2. The graph here has a different slope. Okay? So I can use subtraction in the slope formula and limits to get close. Okay? What happens with my limit is this. If I take the limit as h approaches 0, and I use h because, well, you'll see. Okay? So what is happening in these slope formulas? Well, I take x2 or y2 minus y1. Okay? So this is my function where I add a certain amount on, so f of x plus h, because this, I added a little bit on to my zeros each place here. And then I subtracted my original number, f of x. And on the bottom, we have x plus h, okay, that's my x values, minus x. Now I can simplify that function a little bit to be f of x plus h minus f of x all over, what's x minus x? 0. So it's h. For those of you who have taken college algebra, this thing is known as the difference quotient. Okay? So that's the difference quotient from college algebra. The difference quotient is also the way to find the first derivative of a number. Okay? So we're going to do that by doing a first derivative. Now, f of x is equal to x squared in this example above. F of x is equal to x squared. Okay? So if we use the difference quotient, if f of x is x squared, then f of x plus h is x plus h squared. We're just adding on a certain amount and then squaring it. Because that's what we did up here. Okay? In this example, we added on, h was 1 here. We added on 1 here, and then to find our y, we squared that. H was 0.1 here. And then we squared whatever f of x plus h was. Okay? So in this example, f of x plus h is x plus h squared, which is x plus h times x plus h. What's x times x? X squared. Outers is xh. Inners is xh. Last times last is h squared. So it's x squared plus 2xh plus h squared. That's what f of x plus h is. So to find the first derivative, which is labeled with an apostrophe next to the f, the first derivative of x, which helps us find the slope at any point, is f of x plus h minus f of x over h, which in this case is x squared plus 2xh plus h squared minus x squared all over h. Now let's simplify. What's x squared minus x squared? 0. So it's 2xh plus h squared over h. And while we're doing this, this is the limit of this as h approaches 0. If we factor out an h on the top, we get 2x plus h over h, right? The h's cancel. So I have the limit as h approaches 0 of 2x plus h. So if I stick a 0 in there, I get 2x plus 0, which is 2x. So we say the first derivative of x is equal to 2x. The original problem, f of x, was equal to x squared. So its first derivative is 2x. Okay, let's go up to the top again. So y is equal to x squared, so f of x is equal to x squared. The first derivative of this is equal to 2x. Well, we found the slope at 1 to be what? 2. So if you stick in a 1, you get a 2. We found the slope of 0 to be 0. You stick in a 0, you get 0. So what should the slope at 2 be? 4. The first derivative at 2 is 2 times 2, which is 4. So the slope right there should be 4. And if we wanted to stick in numbers and to find the slope, we could. Okay, what's the slope at negative 1? What's 2 times negative 1? Negative 2. Because it's going down, right? So it would have a negative slope. Okay. I filled your brains with a lot right there, didn't I?
I don't understand that part. So we just this one.
This down here?
Yeah.
This stuff?
Yeah.
Okay.
What's the point doing that? You just trying to find a slope.
Because it can save you time in finding the slope. It'll save you the time needed instead of finding the slope between this and this and this and this and this and this. By having this, if we just plug the number into the formula, I can find the slope anywhere on the line instead of doing 3 examples to see where it works to. Okay? So for tomorrow, you're going to do one problem on page 762. You're going to do problem number 1. Now, problem number 1 is y equals x cubed. Okay? So, for part A, we want to find the slope at 1, 1. Okay? So, for part A, you're given the point 2, 8. So, you're going to find the slope between 1, 1 and 2, 8. And you're going to find the slope. For part B, you're going to take 1, 1, and then 1.5, 3.375, because 1.5 cubed is 3.375. You're going to find that slope. For part C, you're going to go 1, 1, and then 1.1, 1.331, because 1.1 cubed is 1.331. And then you're going to find the slope. And then for part D, you're going to do the limit as h approaches 0 of f of x plus h minus f of x over h, which is x plus h quantity cubed minus x cubed over h. You're going to work out that problem to figure out what it is. Okay, so that's finding the first derivative of x. You're going to find the first derivative, and then you're going to plug the first derivative at 1 into what you get for an answer. So there's basically 5 problems there in problem number 1. So that's what you're doing for tomorrow. And we'll go through this problem, and then we'll get on to going through more stuff. And then we're going to spend a few days on this section because we can.